and welcome to Into the Terminal. We talk about critical system administration skills. Today, we're going to talk about troubleshooting applications. So, Nate, why don't I share us the screen and we can start off with figuring out why Apache is not running on this machine.
Sure thing. Everybody's favorite web server, right? All right, so how do we know Apache's not running? How do we know there's a problem, Scott?
Let me show you. Let me show you. As I monkey with all the screens.
Where'd that browser window go?
Look at all that. That's why we need Eric. Okay, so I connected to my host's web server, and this is what I get.
So let me put everybody in the proper mindset. It's 2 a.m. The boss just called you and said that the website's down. This is what he tells you. This is what he shows you.
Right.
So get your coffee, rub the stuff out of your eyes, and let's start figuring out what's wrong.
So when we go to the website, like they get a connection refused or unavailable message. So where do you want to start, Nate?
So let's see. The website must use some sort of a service in order to actually allow people to connect to it, right? So how do we check on services? We use systemctl, right? We check systemd. We find out if the service that we know. I mean, this assumes that you know what web server you're running, right? You must know that much at least. So systemctl status. And then the name of the daemon would be httpd, which I know is confusing because we always call it Apache. All right, so it says it's loaded. It says it's inactive, right? So that, simple as that, means that either it crashed or someone stopped it. In fact, so a little bit of a log snippet it gives you there tells you that someone stopped it.
Yeah. Another reason maybe it was not set to automatically start at boot time. Like there's a whole bunch of reasons why it might be turned off. So what would we do to resolve our problem?
Well, simplest solution is to just try to start it up and make sure that it comes up. So if you did systemctl start httpd, boom, should come right up.
All right, so that fills me with joy.
Yay.
And then if we, man, gonna have to monkey these tabs again. If we go back to the other tab, and reload. So now it's running, but we get a different problem. So we will troubleshoot that in these after the transition and the deeper dive.
Foiled again.
Yeah. All right, but what are some other troubleshooting techniques that one might want to use when walking into a situation like this?
So I always try to, I mean, step one is do not panic. The Hitchhiker's Guide tells us this. But that's number one. Keep a level head. But number two is have a plan, right? Don't just walk in and scattershot. Start trying to change things. Start trying to restart services. Or have you rebooted it yet? Yes, sometimes that might fix it. But if you don't know why it fixed it, it may just happen again later. So you always want to collect data. Then you want to act on that data, or perhaps research on that data, then act on it, and then see if it fixed it. And then just repeat that cycle, until you fix the problem.
Yeah, and after the transition, we're going to take a deeper look, and we'll talk about some application workflows and like how you can use that to help shape your troubleshooting technique. But some other like just troubleshooting tools in your toolkit, right? So some other commands that one could use.
Mm-hmm.
One that I like is RPM. So when we're working with Apache, I know it's provided by the Apache or the HTTPD RPM, and I know that because I can do a switch, and then I can do an RPM QF.
We don't see your terminal, by the way. I don't know if you Accidentally have to reshare it after the browser.
Well, I'll just go for another 30 minutes and then share it. Thank you, Nate, for keeping me honest.
Do all the things and then just show us how it worked out at the end.
All right, now that should be better. So I did a which HTTPD, and I'm told what executable file it is. I could do an RPM Q F. And what this does is tells me the package that was installed to get me that binary. And from here, I can query for a list of configuration files and maybe even documentation files that may be useful for me later on in my troubleshooting process. All right, so
Yep.
again, that was, if I know the executable, I can figure out what package installs it with QF. Then once I know the package, I can query the RPM database for a list of config files or documentation files that go along with that service.
And this stuff's important, right? So packages installed on a RHEL system and many Linux systems include a ton of documentation that some people might not even know exists, because usually the first thing you want to do is just go to Google. I found this error. I threw it into Google. Google tells me what to do. You end up on Stack Exchange and you try a whole bunch of things that some other admin at 2 a.m. had discovered and tried. But you may not have access to Google. You may be in a data center somewhere at a console and you don't have service on your phone, and you need to be able to know how to find this stuff. So learning how to get docs from man pages, learning how to get data out of RPM, it's all important stuff to know.
Yeah. And to Nate's point about collecting data, a great source of that data would be log files. That, of course,
Mm-hmm.
means that you need to know where your service is logging. So if we know from our list of config files here, there's my primary configuration file.
Mm-hmm.
Maybe I view and search for log.
See, I learned something new. I
Look at
just
that
would have used
eventually.
less. I didn't know view
Well,
was a
view lets me,
command.
yeah, it's like read only VI.
Oh, nice. Which is the same
Yeah.
as less, really.
So here we're told where our errors are logged. And then if we look for access log, no. Just look for logs. Oh, down here, the custom log directive is telling us
Custom
where we
log, yep.
store our accesses. Yeah, because it has a format on like how the logs get stored, and that's why we use
Yeah.
custom log.
That's always been a little bit less than straightforward. Error log is just called error log, but the access log, nope, custom.
Yeah. So over here in we'll do less on that. We'll do a tail on that. Var log HTTPD. Right, we see the error log and the access log, and then it turns out that for secure socket layer connections on port 443, we store those in yet different logs. So you can kind of look at the log files to collect that data to figure out what might be going on with that service. And we'll take a look at that after the transition.
All right.
All right, so stay with us after the transition as we talk more about developing your troubleshooting methodology. I see in the chat there's already some people like chiming in with great tools to use. So we'll cover some of those, and we'll do a couple more troubleshooting scenarios. All right, after the transition, I successfully played it. Yay!
You did. You did it, Scott. Congratulations.
Channeling my inner Eric today. All right. So now is the time where we go a little bit deeper into our topic, but also where we work with the audience to answer questions and collaborate and a variety of other things.
Yeah, so there's already been a ton of chat today. It's great, great interaction, folks. Thanks for joining in.
Yeah. So I see a couple here, like every mentions testing the website with curl. That would be awesome if you didn't have a local web browser to use. You could use that text-based
Hmm.
utility to try and transfer a page. Um, and then Avery also suggests some other tools in the tool belt would be ping, MTR, as mentioned, curl, and telnet. Telnet's actually one of my favorites too.
Yeah, I used that for
Um,
years to test anything network related.
Yeah, and that one I think is really hard for new administrators to get their brain around because they're used to being told Telnet's bad and insecure and all this stuff. It's like, yes, that's all true. However, we're using Telnet to connect to a port, right? We're not actually trying to Telnet and establish a host connection and log into that machine. We're just using it to check port connectivity.
In a job interview long ago, I was asked to send an email using Telnet.
Oh, were you Telnet to port 25 and
Yeah,
give them
exactly.
hello?
Telnet to the SMTP port, issue the commands to send an email. I did it.
Yeah, fun times. All right. So when last we left our Apache web server, we were still having problems with it. So it was running now, thankfully, um, but we got a forbidden message on our web page. So before we dive into what that looks like, um, one of the things that the humans are really good at doing is recognizing patterns. And you probably do this without even thinking about it in your life all the time. Um, so, Nate, do you have an example that you could use on like how we use pattern recognition in our life to change our behavior?
Sure. So, take any task that you do frequently. Before we started the show, Scott, you and I were talking about, driving a car, right? You're driving your car. There's a certain amount of feedback you get from the car, when you hit bumps or whatever, but you kind of get used to those after enough time driving. You kind of get a feel for when things aren't quite right. You hit a bump and there was an extra thud afterward, or you're just driving and all of a sudden you hear a squeal or you hear an extra noise. You intuitively know that, even if you don't know anything about cars. You just know something isn't quite the way it's supposed to be. Uh, if you've got a troubleshooting mindset, then you can start down a path of trying to figure out where the noise is coming from. And then, even if you can't fix it yourself, you have that much more information to give to someone who can fix your car, right? So maybe you pull off the side of the road and you see if the noise stops. Maybe you speed up or slow down and see if the noise changes, right? So,
Yeah, and but in order to use that like tremendous amount of pattern matching and intuition that humans have, you first have to know what normal looks like.
right.
Right? So, like, you know what it normally feels like to drive the car, so you can recognize that abnormal event. And troubleshooting computer problems is similar, right? So, to know what to look for, you first have to know like what's normal look like. So, I threw this together before the show, and Eric is crying himself to sleep tonight on his enormous pillow because I'm showing slideware on into the terminal. But that's because I was too lazy to like figure out how to do work whiteboarding software right before the show. So we got what we got because this is what I got skills on.
This is
Um,
fine. I won't tell Eric if you don't. You think he's going to go back and watch?
Good question. Um, so like this is what kind of normal looks like at a very high level on a web server transaction, right? We get the request in from the web browser on some network port. There's a daemon that's tied to that port that will hand that connection off to a worker daemon. And then the worker daemon does stuff to resolve that request. And that stuff could be picking up a static web page. It could be executing a application, right? Like something written in JavaScript or I don't know, something terrible like Perl CGIs.
I was
So
going to go
it
with
like
I was going to go with PHP, but okay, if you're going to go that far back.
right. Yeah, okay, fine, PHP. Um, and then depending on the output of those, it could also retrieve an error page. But at some point, it's going to like have something to send back to the browser. And that's what it does at the very end is it sends that thing back to the browser. And that could be a web page, that could be um, an error code or a variety of other pieces of data. So that's what normal looks like.
Mm-hmm.
All right. So when we last left our web server, it looked like this.
Find the browser again.
I am working on it.
You need more monitors? Is that the problem?
All right. So it looked like this, right? We got a
Forbidden.
forbidden message.
Yep.
Okay. But we know that the page request was received. It went to a worker daemon. The worker daemon worked to solve that or resolve that request. But what came back to the browser was an error page.
Right. So the key is, and this takes a little bit of intuition, right? The error you're looking at here isn't an error from your browser. It's an error from the web server, which means your browser successfully connected to the server and the server successfully connected to a worker, but the worker encountered a problem and gave you the error back.
Right. And so that means that we can more highly target our troubleshooting to a specific part of this transaction. Right? We don't need to worry about networking things because all the networking things were working correctly. Right? We made the connection to the port. We sent the response back to the browser. We can not have to worry about things like service status, right? Because the daemons were running to then resolve this request, to then send this response to the browser. So let's focus in on the like what happened when we were resolving the request. So Nate, when a web browser experiences an error, what might it do with that?
What might the browser do with the error? Well, it'll just display it to the
Server.
user. The server, on the other hand, what the server's supposed to do is, as long as you've got logging configured properly, is it should log that error somewhere. Now, depending on the service, there's lots of different ways that it could log that. It could end up in the system's journal. It could end up in var log messages. But in the case of the Apache web server, we just showed you before the break that there is an access log and an error log. And those two are immensely valuable when you're trying to troubleshoot web application problems. And I see that we're already getting comments about turning off SE Linux. We're not there yet, guys. Don't just jump to that.
Well, and that's a great point, right?
It is.
You know what? Let's just do that. Let's just turn it off and see what happens.
Right. Right. Now, remember the troubleshooting process I talked about earlier, right?
About not just trying random things?
About not just trying random things.
All right. All right, so now it is in permissive mode. And I'm not going to flip-flop the browser around just because I don't want to bore you with all the flip-flopping, but I just reloaded the page, and sure enough, it still comes back with a forbidden error message. So SE Linux is not the thing this time.
Now, don't get me wrong. I can completely understand the sentiment because there's probably a year in my sysadmin career where I had Post-it notes all over my monitor that says check SE Linux, because it was always the piece I would forget to check when troubleshooting, and I'd spend hours on a thing and realize it was just SE Linux.
All right. So SE Linux may be a path to explore, but just like our other thing that provided a error 403 forbidden, an SE Linux problem would also be logged.
Yep.
Now, it may go in a different log file, but it will be logged.
So keep in mind, SE Linux is just another layer of security in between your application and your file system, right? And several other things, right? But in this case, it could prevent you from reading a file. So it's not a bad idea to check SE Linux. However, there are simpler things that could prevent your web application from being readable by your web server. And we're going to look in the error log now and see right there. Permission denied, right there at the bottom. File permissions deny server access. Now, I'd have to look to see if that error looks different, if it is in fact an SE Linux error. I know it used to be either very similar or the same error. That could be different now. We're talking years ago when I last troubleshot this. But SE Linux will have its own log that tells you when file permissions have been overridden, or not overridden, but denied, or file access, I should say. But in this case, it could be just as simple as, does Apache have read access to the file that we're trying to serve? And it looks like it doesn't. So if you're familiar with file system permissions or POSIX permissions, simple enough. We have read and write for root and the group root. However, the group and others do not have read, write, or anything access, right? So we should be able to just either change ownership to the www user, or add a group, or make it world readable like Scott's doing now.
And actually, I'm going to do both, right? Because if we look at what's in the document root, oh, there's only one thing in the document. How about we look at the LD? Oh, that one's also owned by root. So yeah, this should be all right.
Yep. Now, we could go
Okay.
into a whole dive as to how permissions should be set for a web application, especially one that's dynamic or one that uses an interpreted language. But I don't know if we have time for that on today's show.
All right. So when we last left our poor web browser, we had this, our forbidden error message. But I've gone in and I've updated the permissions so that now the Apache service user has read permissions on this file that was requested. And if I reload the page, we get the most awesome index file ever, right?
Yes. And then we know it's the most awesome because it says it.
Right. So we used our application workflow of like knowing what normal looks like to then figure out where we needed to dig a little bit deeper in our troubleshooting. All right, so let me break this machine in another interesting way.
So while you're doing that, there's a great comment here from the name I'm always going to butcher, Shantanu. Did I get it right?
New.
Shantanu. Hear me out. Product idea: Clippy for Linux, which is monitoring log files and suggesting fixes after telling you what you might be trying to do. So I'm just going to call attention to the shirt I'm wearing today, just by complete chance. But Insights does that for you. I wouldn't call it Clippy for Linux, though. But if you have a RHEL sub and you have a system that's subscribed to the customer portal, you have access to Insights as long as you register it through the Insights client. And it does pretty much what was just described there. It'll monitor log files. It'll monitor a whole bunch of other things. It'll give you suggestions on what it thinks are wrong. Now, I don't know if it'll go as far as to check your HTTPD access logs. But there's a ton of stuff that it can help you with. So just keep that in mind. All right. Is our RHEL system sufficiently mysteriously broken?
Yes, it is. And let me tell you about the phone call you just got from your boss. Okay. Hey, the internet's is down.
The internet's is down. Okay.
Internet's is down.
Okay. Can you get to Pepsi.com? Sorry, that's always my default.
Well, being from Atlanta, I would say Coke, but you know, whatever.
Oh, sorry. In my troubleshooting days, that was the one, because it's easy to say over the phone. People understand what it is because they recognize the brand. Trying to give people the URL to the ISP that I worked for was always like a nightmare in pronunciation. So could not resolve host. That's a tough one.
Yeah, and I see that while we were waiting for our curl to resolve, there was already people throwing in like, check this, check this, check this. However, I have a slide.
Here we go. Back to the slideware. Not
That's
just
right.
one slide, but two slides, Scott.
Man, Eric's going to be so mad. All right. So again, to know where to focus our efforts, we need to know what normal looks like.
Mm-hmm.
So we got that error message about unable to resolve. And that like keys me in that maybe we should look at DNS. And we can do a little bit of further troubleshooting to verify that that is the right direction. All right, but let's think ahead and actually talk a little bit about DNS. So something like curl or a web browser is going to do a DNS lookup request. And the DNS lookup request is going to go to a DNS handler that's on our system that is like a shared library. The DNS handler looks at a configuration file called nsswitch.conf, and based on the data there, chooses where it should do DNS resolutions against. And that could be the content of the etc hosts file. That could be DNS servers listed in the etc resolve.conf, or it could be the local host name of the system. And then based off of which of those it's querying, it will provide a response back to the requesting application. Okay. Nate, do you have any further clarification or anything you'd like to add?
Yeah, I mean, the only thing I would add is that keep in mind that the order of these things is configurable. That NS switch file that's referred to in that second box there, you can tell it to do files before or after the DNS servers and things like that. So this isn't necessarily verbatim, but this is how I think it's configured out of the box. So
Yeah. And in fact, we're gonna like falsely fix this one, I think, as well, just to like jack with Nate's Pepsi.com ridiculousness. All right. So let me stop sharing again and share my terminal one more time. I'm getting faster now.
good, good.
Okay. So curl made this DNS resolver request.
Hmm.
We said that it's going to take a look at Etsy and a switch to figure out where to pull that data.
Hmm.
And the line of interest is this one.
Yep. So there you can see it does files first, which would be like Etsy hosts. Does DNS, which of course is the DNS servers configured in resolve.conf, and then your own local host name.
All right. So somewhere in here is probably the problem.
Right.
And the first thing we're going to do is we're going to take a look at Etsy hosts.
Make sure that somebody hasn't put their own little entry for Pepsi in there. Nope.
Yeah. Which is actually what we're going to do to false fix it, right? Because we could go in and
Oh yeah, that's always fun. You can point it anywhere. This is a great troubleshooting step, by the way, not just to falsely break. Did you actually get the IP for Pepsi.com, or is that an IP you know off the top of your head?
yes. All right. So I added it to Etsy hosts, and now I'm going to do my curl again, and like, whoa, we actually got something, or returned without an error.
Yeah, yeah.
Does it actually have a web page? Is there just some made up drink that you're telling me to
I
use?
haven't checked it in forever. I mean, there's so many websites nowadays that if they don't pass some level of checks before, from the browser string, they don't even serve anything out. So
Okay.
it
Well,
didn't give you an error, so we're gonna assume it's fine. This
okay.
is fine. Everything's
Oh,
fine.
yeah. So you're going to call your boss up and be like, "Hey, boss, I fixed it."
I fixed it.
Yeah, but did you fix it?
Fixed it for that particular site, sure. And to be honest, I don't think anybody really expects that adding it to the hosts file is a fix, unless it's a thing that does not already exist in DNS, and you're like, in a dev test environment, right?
Fair. Fair. I just wanted to show you that like changes in the file
Yeah.
contents actually produce different results that you weren't
Yep.
expecting.
Yep. Yep. But the other thing to remember is if you need to for some reason override DNS for something that does exist, you can put it in your host file. If you didn't know that already, right?
Oh, that's true. We can because hosts get checks first because of the
Yep.
nsswitch.conf, that's where we will check and resolve the DNS record
Yep.
without talking to the DNS server.
And there's still like some ad blocking software that does exactly that. It just dumps a whole bunch of ad services into your Etsy hosts and points them to localhost.
All right. So I want to do a couple other things to just confirm before we actually delve into resolve.conf. that this is really a DNS problem, right? Because isn't there a poem about this, Nate?
There's a haiku, in fact. I don't know if
Yeah.
I know off the top of my head. It's like it's not DNS. It can't be DNS. It was DNS.
Yes, that is exactly correct. All right. So we can verify that if we do something like a ping, let's do Google. That's my go-to for testing things.
Yeah, yeah.
Right. That doesn't work.
To be
Right.
fair, my tech support days are like during the infancy of Google, so it wasn't a common name yet.
Um, but we could see that if we ping something by its IP address, right, where we're like not using the DNS infrastructure at
hmm
all,
hmm
that worked just fine.
Yeah,
Um,
so that's
like,
actually like a really good troubleshooting step because Google, one of their DNS servers is just 8.8.8.8. Really easy to remember, really and it's pingable, right? So it's a great number to keep in the back of your head for when you're trying to troubleshoot network related things.
all right. So networking seems fine. We're getting network traffic out of our network. We're getting responses back into the network. So we can avoid like going down a whole bunch of network weirdness. Like,
Right. So this
wait,
this tells us we can get to the internet. It means routes work. We have an IP address. We're connected to the network. You may already know some of that stuff, but this kind of validates it, right?
right. And so really the problem is that when we substitute in the host name, all of a sudden things break. And we know that we checked etc host already. Don't think that's the problem. The next step would be the resolve.com file.
Right. What name servers are we set up to use?
Okay, so this is what my resolve.com file looks like. And you may see a problem there, Nate.
192.168.1.1. Does that actually respond as a name server?
Good question. Is that even on our network?
That's another really good question.
Yeah. And so, you know what? I'm just going to change this to a DNS server I know will work. And then we're going to try our curl one more time. Is that right? 4.4 and 4.2? No, it's 4.2.2.2.
So
Man, got the
that's
right
why I
stuff.
just use 8.8.8.8. You only have to get one number right.
Fine, we'll do that then, Nate. All right. All right. And now it works just fine.
And
Right?
Red
If we,
Hat does the same thing Pepsi did
yeah.
by returning nothing.
Right. But when we use our other tools like ping with
There we
DNS
go.
records, we're getting responses back from the host name that goes with it. All right. So at this point, we've fixed the problem. Kind of. We fixed
Kind
it on
of.
this machine.
Sure.
Yeah. But it was our boss that called us up and told us the internet was down. Did we fix his machine or her machine?
I guess that's a really good question. Call the boss
So
back.
this might like push us in a whole nother direction of like,
Right.
what was the DNS server settings provided by the DHCP lease?
Right. Well, not just that, it could be maybe 192.168.1.1 is in fact a valid name server and it's down. Is that under your control, right? Now, that is a local address, right? So theoretically it would mean it's a local name server, but
Yeah, but it could be another team that does that.
it could
Or
be.
that
Well, then
like
all that
one
means is that it's not your problem anymore and you can call the network guy and go back to bed.
yeah. And in reality, we all know that the DNS administrators are some person that lives in a dungeon and they're like chained to their desk and people throw them scraps of food occasionally because that's the life they live.
Always getting the blame. Them and the firewall guy, they live in the same room.
They do. They actually have matching desks.
Yeah, right.
Oh, um, so yeah, like that's kind of how we approach troubleshooting, right? And there are a whole bunch of diagnostic tools that we can use, like ping, netstat, telnet. So while we're here, let me go ahead and use telnet because I want to show that one. I like that one a lot. So if we do a telnet, whoops, host 80.
hmm
So telnet is a tool that makes a connection to a remote host. You tell it the remote host you want to connect to, and then you can also pass a port number. The default port it would try would be 23, which is the telnet service port. But here we're telling it to attach to port 80. Oops. It would help if I have it installed.
You don't have telnet installed. Not installed by default anymore, which makes me sad a little bit, although I understand why. Don't use telnet, use dev TCP dest port. Yeah, I guess that's valid, although telnet is a lot easier to type.
Yeah. So that's using the
Cat,
network network subsystem of the kernel to just make a direct port connection. But one of the reasons I like telnet is that we get this interactive shell. And so we do things like
Yeah.
interact with the thing that's running there. And just that interaction could tell you some additional data. So for example, here it gives me back an error page from Apache. So I know that the service is running. I know that it is SSL 301 compliant. And I get some more data back from it. We do the same thing to port 22. And I'm told what service is running there. And actually what a lot of your network port scanners and stuff will utilize to get data back that they then beat you with their auditing report.
Yep. Yep. Yeah, it's a common lockdown technique to make services not tell you what's running because it's another obfuscation technique, right? So like Apache, you can tell Apache not to report its version, for example, right?
Right.
Although that doesn't really fix anything. It just means that the attacker doesn't know his target yet.
And Avery asks why I use Yum and not DNF, muscle memory.
Yeah, it's
Because
habit.
check this out. Look, they're
Yeah.
actually the same.
Just the symlink. Someday, Scott, that it's going to be deprecated. In fact, it's probably already deprecated. Someday it's going to be removed.
Yeah.
And then you're going to have to learn.
Well, it's more I need to adjust my muscle memory.
Yeah.
Right.
Yep.
When we write labs and stuff, we're already using DNF as the basis for our labs. So it's just getting in the habit of using it. Kind of like not using telnet, as Diablo Espana points out.
Yep.
So
you can use netcat too. You don't have to use cat with that dev sys thing, right? Come on. Get creative. You could write your own TCP socket and do it that way too. Get out your Python.
All right. Well, we're at the close of our time together today. Nate, any final parting words of wisdom?
Don't just turn the radio up.
That's right. Figure out how it actually works.
Yep.
And then walk through that workflow to figure out what might be the problem. Right. But you can't just like show up and start doing things like turning off SE Linux because you think that's the problem without gathering any data beforehand, because that'll just lead you to things that you need to undo later.
Indeed. Oh, and keep a notebook or keep a log of what you changed, because if you do have to undo them, you're going to want to know what you changed.
Yep. All right. Well, thank you all for being with us today. If you're watching deferred, I hope you enjoyed it. Don't forget to like and subscribe. And if you think somebody else would get a hoot out of this video, send it to them with a share. All right. Take care, everyone.
Everybody have a good one.